So here in this problem, we need to find out the coordinates of the point of intersection of the axis and the directrix of a parabola with focus at 3, 3, and the equation of the directrix is given. We also need to find out the length of the lattice rectum. So let's begin. Let's try to understand the problem graphically first. So here we are considering a line. So let's say this is the axis of the parabola. Now on this axis, we are going to consider a point which is going to be represent the focus of the parabola. It has the coordinates 3, 3. Now on the same axis line, we're going to consider another point. Let's say that is point A, and we're going to pass a line through this point A, and it is going to be perpendicular to the axis. So this line will be the directrix of the parabola. So our first task will be to find out the coordinates of point A. So let us begin by first considering the equation of the directrix. So here we have the equation of the directrix that's given by 3x minus 4y equals to 2. We're going to rewrite the terms. So here we can rewrite 4y as equals to 3x minus 2. We can divide each terms on both sides with 4 to get y equals to 3 over 4 times x minus 2 over 4. So that's going to be 1/2. All we have done is rewrite the equation, but when we rewrite in this particular form, we get the slope-intercept form of a line, which will be y equals to m times x plus c. Here m represents the slope and c is going to be the y-intercept, which means that our slope, let's say the slope is denoted by m1, that will be equals to 3 over 4. So this is the slope of the directrix line. Fine. Now, the reason why we first try to find out the slope of the directrix line, because using the slope we can find out the slope of the axis line, because the two lines are perpendicular to each other and we have a property of straight lines. That means whenever our two lines are perpendicular to each other, then the product of their slope equals -1. So we'll consider the slope of the axis of symmetry line to be m2, where m1 times m2 equals to -1. Now since we already have the value of m1, that means that m2 will be equals to -1 over m1, or we can say it's -4 over 3. This is going to be the slope of the axis of symmetry line. Now that we have its slope, we can easily find out the equation of the axis. All we can do is use the point slope form, which states that if we have a straight line passing through a point with coordinates x1, y1, and the slope of that line is given, then the equation of the line can be obtained by using the equation y minus y1 equals to the slope multiplied to x minus x1. So here we have the slope, that's -4 over 3. We have the point, which is the focus, 3, 3. So equation of the axis of symmetry line will be y minus y1. So y1 will be 3 here. Will be equals to -4/3 of x minus x1. So x1 will be 3. Fine. So that will be equals to, so we'll multiply both sides by 3 to get 3y minus 9 equals to -4 times x minus 3, which gives us 3y minus 9 equals to -4x plus 12. Oh, we get 4x plus 3y and -21 equals to 0. So this is going to be the equation of the axis line. Now that we have the equation of the directrix, we have the equation of the axis line, we can solve these two equations to find out the coordinates of point A and point A. So let's do that. So here we have two linear equations in x and y. We can use any standard method to obtain the values of x. So here x is going to be 18 over 5 and y is going to be equals to 11 over 5. So that means the coordinates of the point of intersection. So we have computed the first part. The points of intersection will be 18 over 5, 11 over 5. Our next task is to find out the length of the lattice rectum. Now, to find out the length of the lattice rectum of the parabola, there is a formula. We have to take 2 times the perpendicular distance of the focus, which is having the coordinates 3, 3, from the directrix line. Now, once we compute that value, we can easily find out the length of the lattice rectum. So the perpendicular distance is simply AF. So we have 2 times AF. So we can find out AF by using the distance formula. So we have 2 times the square root of, so here we have 18 over 5 minus 3 whole square. This is going to be the difference of the x coordinate. Added to, we have 11 over 5 minus 3. That's going to be the difference of the y coordinate. Square it, and that's going to give us 2. And that means the length of the lattice rectum is going to be 2 units.